Hi, my name is Hannah Bazemore, and I am an 8th grade student at the Halls Brookline Middle School. My science teacher explained to me the Young Scientist Challenge, and immediately I began thinking. I thought about how both my dad and my grandfather needed rotator cuff repair surgery, but I also thought about the high failure rate of the surgery. Various surgical techniques are used to attach suture threads to PEEK plastic or titanium anchors, which then screw into the bone for tendon reinsertion. The problem with this surgery is that there's an up to 90% failure rate due to screws pulling out. The first question we have to answer to find the solution is, why do they pull out? The problem with a titanium screw is that it is denser than bone and hydrophobic, which means the bone doesn't like it, so in result it does something called stress shielding, which is when it deteriorates around the screw and becomes mushy so the screw pulls out rather easily. Titanium is also bad for X-rays because it creates a reflective scatter, which makes it hard to depict bone from screw. The problem with PEEK plastic screws is that they are also hydrophobic, so the bone stress shields and deteriorates around the screw. The solution to this problem would be to create a bioactive screw which is hydrophilic, so it blends into the bone. To make a bioactive screw, you'd need to roughen the surface, but if the crevices were too deep or too shallow, the cells wouldn't grow and it would still be hydrophobic. To be hydrophilic, the crevices would need to be within 20 to 50 nanomolars deep, so you need an extremely precise machine. One machine, the NXL 100, uses atoms to make crevices which are the perfect depth for cell growth. The machine creates a vacuum environment and adds atoms to the structure while they're in a gaseous state. The atoms form a cluster, are ionized, and then they are accelerated. After this, the atoms let go from the cluster and continue toward the screw to roughen the surface. Accelerated atoms make a one-of-a-kind surface, which is perfect for bone and cell growth. The new bioactive screw could be used for tendon reinsertion, and since it is hydrophilic, the bone would grow into it and stop screws from pulling out. This product could be used worldwide to drastically reduce the failure rate of rotator cuff repair surgery.